So welcome to the class again. In continuation of our earlier class, we will be talking about types of quadrilateral. Okay, special type of quadrilaterals. First, we know that a quadrilateral is a polygon, a four-sided polygon. Polygons means it will be made up of line segments and it will be close and it will be a simple curve, means the line segment will not cross each other. So one of them is parallelogram. Every quadrilateral is not a parallelogram. There are other quadrilateral which are not parallelogram. But in parallelogram, the opposite sides, okay, opposite sides are parallel. That means in this parallelogram, A, B, C, D, AB is parallel to CD. Okay, AB is parallel to this CD. And again, DA is parallel to BC. Okay, so opposite sides are parallel, and at the same time, the opposite sides are of equal length. That means AB equal to CD and DA equal to BC. And the diagonals bisect each other. That means it has two diagonals because it is a quadrilateral. The diagonals are AC, the diagonal AC, and DB. These two diagonals bisect one another. What does it mean? It means that the diagonal will bisect each other at this point O. So OD equal to OB and OA equal to OC. It doesn't say that OA equal to OD. Okay, don't confuse. It doesn't say OA equal to OD, but it says OD equal to OB and OA also equal to OC. This is the meaning that the diagonals bisect each other. So once again, parallelogram. In parallelogram, the opposite sides are parallel. At the same time, the opposite sides are of equal length. Again, I repeat, AB parallel to CD. Same thing, AB equal to CD. AD parallel to DA parallel to BC. At the same time, DA equal to BC. And also, the two diagonals bisect each other. So OD equal to OB and OA equal to OC. This is about parallelogram. Now we move down to rhombus. Rhombus is also a parallelogram. It's also a parallelogram, but with one additional quality where all the sides are equal length. It is again a parallelogram. Rhombus is also a parallelogram, but the opposite sides, not only the opposite sides, but all the sides are of equal length. So, since this being a parallelogram again, the opposite sides are parallel. PQ parallel to RS, PQ equal to RS, SP parallel to QR, SP equal to QR. Since this is also a parallelogram, the opposite sides are parallel as well as equal in length. And again, the diagonal SQ, if I have to draw the diagonal here for this rhombus, these two diagonals, PR and SQ, okay? So again, if we have O here, okay? So here again, OS equal to OQ, OP equal to OR. The diagonals bisect each other, yes. So all the properties of parallelogram will also be in rhombus, but with one additional property where the diagonals are perpendicular to each other. That means, what does it mean? It means that this angle will be 90 degree. Okay? This angle will be 90 degree. Okay? So this being 90 degree, all will be 90 degree because they form a linear pair. So this will also be 90 degree. If I look on this side also, they form a linear pair, this angle and this angle. So it will also be 90 degree. All will be 90 degree. So they form 90 degree. That means the two diagonals are perpendicular to each other. But in a simple parallelogram, this and this are not perpendicular. Two diagonals are not perpendicular, so they do not make in a simple parallelogram 90 degree. Okay, they are not perpendicular in a simple parallelogram, but in rhombus, which is also a parallelogram, the two diagonals are perpendicular to each other. That means these angles are 90 degree. These four angles will be 90 degree. They are perpendicular to each other. This is in addition to the property of parallelogram. This is additional property of rhombus because all the sides are of equal length. The proof of this I will give you in the next class. But today we will try to know the qualities and properties of this special type of quadrilateral. And so continuing with this, I move down to rectangle. Are you following? Are you following?
Yes.
Another is rectangle. Rectangle is also a parallelogram. Rectangle is also a parallelogram where one of the angle is 90 degree. If I say one of the angle is 90 degree, that means all the angle will be 90 degree. Why? Why? Because we know that rectangle is a parallelogram and parallelogram is a quadrilateral. Rectangle is a quadrilateral. So all the interior angle together will make you 360 degree, will give you 360 degree. Since one of the angle is 90 degree, one of the angle is 90 degree, and this being a parallelogram, opposite angles are equal. Opposite, we haven't talked about angles. Let me move up to parallelogram and just I want to add another property to parallelogram. In a parallelogram, the opposite angles are equal. Okay, opposite sides are equal and opposite angles are also equal. These two angles are equal. In parallelogram, opposite angles are equal. Okay, and this angle also equal to each other. The two opposite angles are equal. Okay, and the adjacent angle will form 180 degree. Okay, because they are on the interior angle on the same side of the transversal. You know, because DC and AB and CD are parallel. AB and CD are parallel. So, and again, DA is a transversal between two parallel lines and this transversal DA. This angle ADC and this angle DAB are angles on the same side, interior angles on the same side of the transversal. Okay, so the two angles are interior angles on the same side of the transversal, and they together gives you 180 degree. So the adjacent angles will be supplementary in a parallelogram, and the opposite angles are equal to each other. To prove this opposite angles are equal, we need two prior knowledge. One is the properties of parallel lines and transversal, and another knowledge is about congruence theorem, where we will be able to prove that these in a parallelogram, the opposite angles are equal. So in a parallelogram, the opposite angles are equal. I will tell you later, but let us continue with the properties of this special type of quadrilaterals. Okay. So opposite angles are also equal in a parallelogram. The adjacent angles are supplementary in a parallelogram. The opposite sides are parallel as well as equal, and the diagonals bisect each other in a parallelogram. We have talked about rhombus. Rhombus is also a parallelogram. Additional property was that all the sides are equal in length, and the diagonals are also perpendicular to each other, in addition to bisecting each other. Now the third is rectangle. In rectangle is a parallelogram where one of the angle is 90 degree. If one of the angle is 90 degree, all the three angles will also be 90 degree. How? Because if this angle is 90 degree, this angle will also be 90 degree. If this angle is 90 degree, this angle will also be 90 degree. Because rectangle is also a parallelogram, the opposite angles are equal. Okay, again, the adjacent angles are supplementary. So this being 90 degree, this will automatically becomes 90 degree. And these are adjacent. So if one of these is 90 degree, this will also be 90 degree. So all the four angles will be 90 degree in a rectangle. That's how we prove. Because this is also a parallelogram. Rectangle, the opposite sides are parallel. That means KL is parallel to MN, NK is parallel to LM. At the same time, KL equal to MN and NK equal to LM. Because this is a parallelogram, the opposite sides are equal as well as parallel to each other. But additional property is that one of the angle is 90 degree. That means all the four angles are 90 degree automatically. That's how we prove. Because once again, the opposite angles are equal. Because this being a parallelogram, the opposite angles are equal. If one of them is 90 degree, this will also be 90 degree. And the opposite adjacent angles are supplementary, because this being a parallelogram. Rectangle is also a parallelogram because the opposite sides are parallel. So if this is 90, this will also becomes 90. Automatically, similarly, this will also be 90. So all the four angles will be 90. Okay, let us check about the diagonal property about rectangle. So this being a parallelogram again, rectangle is also a parallelogram. It's a parallelogram. The diagonal will bisect each other. The diagonals will bisect each other. Okay, the diagonal will bisect each other. That means these ON and OL will be equal. OK will be equal to OM. I am not talking OK equal to ON. Okay, I am not talking OK equal to OL. I am talking ON equal to OL. OK equal to OM. The diagonals bisect each other. Okay, at this intersecting point O. So the diagonals bisect each other because rectangle is a parallelogram. In a parallelogram, the diagonals bisect each other. But another property of the diagonals of a rectangle is that both the diagonals are equal in length. This is not true in the case of a simple parallelogram. Also, this is not true in the case of rhombus. In a rectangle, the diagonals are also equal. This can be proved by the knowledge of congruence theorem. You look at these two triangles, NKL, this triangle, NKL, NKL, okay, NKL, and MLK, NKL triangle, and the another triangle, MLK. Look at these two triangles. Let us prove that these two triangles are congruent, one by one. NK is equal to ML because opposite sides are equal. KL of the first triangle and LK of the second triangle are both common. KL of the first triangle and LK of the second triangle are common to both the triangles. And another thing is that the angle NKL and the angle MLK of the second triangle are 90 degree. So they are equal. So by SAS congruence theorem, S, the side S, NK, the angle NKL, A, the side KL, SAS. Look for the second triangle also, the side MLS, the angle MLKA, and the side LKS, SAS. By SAS congruence theorem, these two triangles NKL and MLK are congruent. So, automatically, by congruence part of congruent triangle, the side LN and the side NKM are equal. That means the diagonal NL and diagonal KM are also equal. This is another additional property of a rectangle. So rectangle, once again, rectangle is also a parallelogram. The opposite sides are parallel. The opposite sides are equal. The diagonal bisect each other. In addition, the diagonals are also equal in length. But the diagonals do not bisect each other perpendicularly. That means these two diagonals do not make 90 degree. Okay, they do not bisect each other perpendicularly, but they simply bisect each other. ON equal to OL, OK equal to OM. And since the two diagonals are equal, we can also say that OK equal to OL, OM equal to OM, because they are equal. The two diagonals are equal, so their half will also be equal. The two diagonals are equal, their half will also be equal. So in a rectangle, the diagonals are equal to each other, but they are not perpendicular. This is true in the case of rhombus, but this is not true in the case of rectangle. But in rectangle, the diagonals are equal in length. For rhombus, why they bisect each other perpendicularly? This can also be given by the knowledge of congruence theorem. By the knowledge of congruence theorem, rhombus, you can check out you can check out how they bisect each other perpendicularly in rhombus. I will be very quick, just try to listen carefully. I will very quick here, but try to. So look at these two triangles, this triangle and this small triangle, small triangles. Okay, these two triangles. We will return to these two triangles, but this being a parallelogram, first you try to know this let us start with these two triangles. Okay, this triangle and this triangle. Okay, you see that this angle is equal to this angle, because in parallelogram, sorry, SR, PQ is parallel to RS, PQ is parallel to RS, and SQ is a transversal. SQ is a transversal. Forget about the other lines. Just try to see the two parallel lines, PQ and RS, and the transversal SQ. Transversal SQ happens to be the diagonal, but just forget about that. Just try to see the two parallel lines, PQ and RS, and the transversal SQ. So these angles that I have marked are interior angles on the opposite side of the transversal by the property of parallel lines and transversal. So these two angles that I have marked are opposite angles, interior angles on the opposite side of transversal. So they are equal. Okay. Similarly, this triangle that I am marking now and this triangle I am marking now, okay, these two triangles are also opposite angles, interior angles on the opposite side of the transversal. When we change the transversal from SQ to PR, okay, the same parallel lines remain, PQ and RS, but I have changed the transversal as PR. And these two triangles are also equal because they are interior angles on the opposite side of the transversal, one being here and one being on the other side of the transversal. one being on the left and one being on the right of the transversal. So these two angles are also equal. So let us come back to congruence theorem. This angle of this small triangle SOR and this angle of this small triangle PQO, okay? If I say SRO, okay, let me say in anti-clockwise, PQO, if I say PQO for this triangle, then for this triangle, it will be correspondingly P means R, Q means S, O means O. So if I name this triangle as PQO, this will be called RSO correspondingly. P corresponds to R, Q corresponds to S, O corresponds to O because they are vertically opposite angles equal. But by congruence theorem, let us check ASA. Opposite sides are equal for a rhombus, this being a parallelogram. So opposite sides are parallel. So by SAS congruence theorem, SAS, S, this I'm not saying this S, but side, ASA, angle, side angle, angle, side angle. This angle equal to this angle equal to this angle. So ASA, by ASA congruence theorem, the two triangles are congruent. Okay, this means what does it mean? This means that this what does it mean? So if these are congruent, and further this is a parallel again this is a parallelogram, they bisect each other, we know. Yes, it can be proved they bisect each other because they are corresponding part of congruent triangle. OP, let's say, OP will be equal to OR correspondingly. OP, P corresponds to R. So OR, these two will be equal. That's why we say that the diagonals bisect each other for a parallelogram. I'm talking about rhombus, but rhombus being a parallelogram, it's the same thing. If I have done it for parallelogram, it's the same thing because these two sides are equal. And again, OS corresponds to OQ correspondingly. So these two sides are equal. That's how the diagonal, we say the diagonals bisect each other. Okay. Another property is that the adjacent sides are also equal for a rhombus. Okay, for a rhombus. So I have shown the proof why the diagonals bisect each other for a rhombus. But if I have done it for parallelogram also, same thing you will get because the opposite sides are equal for the simple parallelogram also. And the opposite and this being parallel, and this being the transversal, PQ and SR, same thing should have happened in a simple parallelogram also, because these interior angles will be called, these interior angles will be equal. So I can prove that the diagonals bisect each other. This is the proof that the diagonals bisect each other for a simple parallelogram. This is also true in the case of rhombus that I have shown here. So we know that the diagonals bisect each other for a simple parallelogram. This is also true in the case of rhombus. But in addition, rhombus has the additional quality that this angle is 90 degrees. Let us prove that this angle is 90 degrees. Look at these two triangles, this triangle and this small triangle, that is SPO and SRO. Okay. In these two triangles, SP equal to SR, adjacent sides are also equal in a rhombus, and SO is common to both. Okay, SO is common to both. And again, since the diagonal bisect each other, OP equal to OR. That is what I have just shown. So OP equal to OR because the diagonals bisect each other. So OP equal to OR. By SSS congruence theorem, because SP corresponds to SR, SO corresponds to SO, common, and OP corresponds to OR. The diagonals are half here. So bisect each other. So SSS. By SSS congruence theorem, these triangle SPO and SRO are congruent. So corresponding part, this angle and this angle should also be equal. But they form a linear pair, 180 degree together. So again, they are equal. So both should be 90-90. That is how we say that the diagonals of a rhombus are perpendicular to each other in addition to bisecting each other. Okay, this is how we prove. By the knowledge of parallel lines and transversal, and by the knowledge of parallel line and transversal and congruence theorem, we have proved that in a simple parallelogram or in rhombus also, the diagonals bisect each other. And by knowing that idea, by the property of SSS congruence theorem, we can prove that the diagonal of a rhombus also are perpendicular. But in a simple parallelogram, it will not be, because in a simple parallelogram, the adjacent sides are not equal. So these two triangles will not be congruent in a simple parallelogram. This is what I'm talking, that in a simple parallelogram, the diagonals, these two triangles will not be congruent because these two sides will not be equal. So additional quality of property of rhombus we have talked, and we have also talked about additional property of rectangle. Rectangle is also a parallelogram. Again, the diagonals are equal in addition to bisecting each other. This also we have proved by the knowledge of congruence theorem. Opposite angles are equal because parallelogram, all the angles are 90 degree. Okay. Opposite sides are parallel, opposite sides are equal, the diagonals bisect each other, and the diagonals are also equal. Let us move to square. A square is also a rhombus, but again, square is also a rectangle. At first, square is a parallelogram because opposite sides are parallel, PQ parallel to RS, SP parallel to QR. So opposite sides are parallel. In addition, opposite sides are equal in length. Adjacent sides are equal. All the sides are equal in length. That means adjacent sides are equal in length. Like a rhombus, all the sides are equal in length. And again, like a rectangle, all the angles are 90 degree. One of the angle is 90 degree, automatically all the angle will be 90 degree. As shown earlier in the case of rectangle. So rectangle, in a square, all the properties of rhombus, all the properties of rectangle, all the properties of parallelogram will be here in square. So all the properties of parallelogram, rhombus, and rectangle, because it has all the qualities. So in a square, the diagonals will be equal, like a rectangle, SQ equal to PR. Like in a rhombus, the diagonal will be bisecting each other at 90 degree. So since this being a parallelogram, the diagonals bisect each other. The opposite sides are parallel, the opposite sides are equal. This is about square. And so square is also a rhombus, square is also a rectangle, square is also a parallelogram. Rectangle is a parallelogram, but rectangle is not a rhombus. Again, rhombus is a parallelogram, rhombus is not a rectangle. So all squares are rectangle, all squares are rhombus, all squares are parallelogram, all rectangles are parallelogram, all rhombus are parallelogram, but all parallelogram are not square, all parallelogram are not rectangle, all parallelogram are not rhombus. There are other simple parallelograms. Again, all quadrilaterals are not parallelogram, but all parallelograms are quadrilateral. So in the family of quadrilaterals, there are quadrilaterals which are parallelogram. There are other which are not parallelogram. But within the family of parallelogram, which is within the family of quadrilateral, I repeat again, within the family of parallelogram, which is within the family of quadrilateral, I'm talking about inside the parallelogram, in the family of parallelogram, there are rectangle, there are rhombus. Again, you can put square in the family of rectangle. Also, a square can be put in the family of rhombus. Rhombus, which is also inside the family of parallelogram. Now let's talk about kite. Kite is unlike parallelogram. So kite is outside the family of parallelogram, but inside the family of quadrilateral. In the big family of quadrilateral, there are parallelograms. Inside the parallelogram, there are many families, which are rectangle, which are rhombus. Square also, within the family of rhombus you can put, within the family of rectangle you can put. But kite is outside the family of parallelogram, but it is still inside the family of quadrilateral because it is still a quadrilateral. Now kite, the adjacent sides are equal, but it doesn't talk about parallels. Okay, if in a quadrilateral, when exactly two pairs of equal consecutive sides, okay, like this, consecutive sides are equal, AB equal to AD, BC equal to DC. So this is a kite. Like yesterday we have talked the you see, this was the line of symmetry. That means this diagonal AC divides the kite into two halves, congruent halves, because this side is equal to this side BC equal to this side DC, okay, and AC is common to both. So SSS congruence theorem you can apply, and you can say that both the triangles are congruent. So AC is the line of symmetry. So again, so you can prove that angle B equal to angle D by corresponding part of congruent triangle, because these two triangles are equal, congruent, so their corresponding parts will also be equal. That means it uh, since this is dividing the line of symmetry is dividing the kite into two congruent triangles. Congruent triangles means triangle has 6 parts, 3 angles and 3 sides. So this angle will be equal to each other. B corresponds to D, okay, and but angle A will not be equal to angle C. Angle A will not be equal to angle C. Why? Because for angle A, this and for the two triangles, this angle and this angle will be equal, corresponding part of congruent triangle. Because if I say ABC for the first triangle, then for the second triangle, it will be called ADC. So looking at corresponding part of the naming, AB equal to AD, okay, BC equal to DC, I will say BC equal to DC because B corresponds to D, and A corresponds to A itself, okay, A corresponds to A itself. So these two will be equal and these two will be equal. Corresponding part of C corresponds to C. C of the first triangle corresponds to C of the second triangle. Because when I say ABC, because I'm looking for the corresponding part, because these two sides are equal. First, AD, AB, okay? AD, AB. So A corresponds to A itself. And BC, when I say BC, I will say DC. That's why B corresponds to D and C corresponds to C itself. So these two CC, the C will be equal, the A will be equal. So, but A is not, the big A is not equal to big C. So these two opposite angles are equal, but the other opposite angle is not equal. Again, one of the diagonal bisect each other. The one of the diagonal bisect the other diagonal. So you can see this. If I put an O here, okay, I put an O here, and look, see this. This is O here. This is the O. Okay, it's very far. So OD will be equal to OB, but OA will not be equal to OC. Both the diagonal will not be bisecting each other. The other diagonal will bisect the other diagonal. Okay, one diagonal will be bisected, not the two diagonals. Okay, so OD will be equal to OB. This is a property of kite. So the diagonals are perpendicular to one another. Yes, they are perpendicular to one another. You can also prove this by congruence theorem. This is for you to prove. I have left it for you as a homework. So this is how we have talk about the quadrilateral, special type of quadrilateral, parallelogram, rhombus, rectangle, square, and kite. For the kite, try to prove it. Okay. Thank you for joining the class. And once again, keep revising your class. Okay. Thank you.